right? We talked about the 4 different transformations. You guys had time yesterday to work on that with Desmos. We finished the whole first page. Let's turn to this next page here.
Any extra copies?
I don't. I really don't. I don't know what happened to all of them. I had plenty. I had more than enough, and they're all gone. So Addison, you can get one after break. Fill it in. Jackson, will you close the door? It's going to get really loud in the hallway. Thank you. Okay. Basics of transformations. Let's look here and decide what happened for figure A to go to figure B. What transformation?
It mirrored it.
It reflected, right? So we have a reflection. How about from B to C? Rotation. How about C to D? Translation. And then what about D to E? Dilation. And do we have an enlargement or a reduction? Right, it increased in size, so that would be considered an enlargement as opposed to a reduction. Okay, which of the following describes how you can tell which figure in a transformation is the original figure? So which of these tells us which one is the original? Right, the figure without prime. Which of the following is a true statement about dilation? Which of the following is a true statement about dilation?
A.
It is A, right? It does not change the orientation or the vertices. It only changes the size. Okay, so now we have a situation where Mrs. Hannigan is moving a couch. This is the perfect opportunity to watch a clip of my favorite episode of Friends. So we're going to do that right now.
We're going to watch Friends.
We're going to watch a clip. So the setup of this is that Ross did not want to pay for shipping. He didn't want to have to pay for his couch to be delivered to his home. So he said, it's fine, I can get it up to my apartment on my own. So that's what's happening here.
Come on. All right, okay. Here we go. All right, ready? Turn. Okay. Turn. I don't think we can do it anymore.
I just don't think it's going to fit.
Oh, yeah, well, come on. Up. Yes. Here we go. Pivot. Shut up. Okay, I don't think it's going to pivot anymore. You think? All right, let's bring it back down and try again. Oh. Okay, yeah, I think it's really stuck now. I can't believe that didn't work.
I know, me neither. I mean, you had a sketch.
Oh, you know what did you mean when you said pivot? I'd like to return this couch. I'm not satisfied.
Return this couch. It's cut in half.
That's what I'm telling him.
So you cut this couch in half.
This couch is cut in half. I would like to exchange it for one that is not cut in half.
You're telling me this couch was delivered to you like this?
Look, I'm a reasonable man. I will accept store credit.
I'll give give you store credit in the amount of $4.
I will take it.
I just like that episode. You guys ever seen the whole episode? So good. So good.
Mickey Mouse, I hate.
Okay, back to Mrs. Hannigan and her couch. She rearranged the furniture. Go ahead and mark each statement as true or false. True or false. Go ahead and mark each of those statements true or false about how she rearranged her couch. Okay, statement A says she reflected the couch. True or false?
False.
Statement B says she changed the orientation of the figure. And she changed the orientation of the vertices. It's actually true because if you look, this goes clockwise and this goes, oh wait, they both go clockwise, don't they? Yep, so that's true. All right. Fill in the statements below with sometimes, always, or never. A reflection will sometimes, always, or never change the orientation. It's always, right? Because the orientation is now flipped entirely. So the A, B, C, D, or what have you on the figure is definitely not in the same location. A reflection will always, sometimes, or never change the size of the figure. Never. A reflection will always, sometimes, or never change the orientation of the vertices.
Sometimes.
Depends on if it's a horizontal or a vertical reflection, so that's a sometimes. Okay, let's look at 6 and 7 up here at the top right. The graph below shows a rotation.
What?
The graph below shows a rotation. Graham thinks that the shape was rotated from quadrant 1 to quadrant 4. Is he correct? Why or why not? So just as a reminder, here's quadrant 1, 2, 3, and 4. So is he correct? Did it go from 1 to 4? Can you explain it? Emma, why do you say no?
Because the A has the apostrophe in quadrant 1.
So it really went from 4 to 1. Right? It went this way, and we know because of the A prime, that tells us that's the image, and this is the pre-image.
Wait, what do you mean it rotated from?
Oh, it should say 4 to 1, shouldn't it? Rotated from 4 to 1. These are Roman numerals.
What do you mean 4 to 1?
Because it didn't actually go from 1 to 4.
It didn't go 1 to 4. It went 4 to 1 because this is our pre-image because there's no apostrophe. And this is our image, right? So this is where it started, and this is where it finished. So it either went 270 or it went counterclockwise 90, but it definitely did not go from 1 to 4. Okay, last one. The graph below shows a dilation. Shelley says that the original image was enlarged, but Steve thinks the original image was reduced. Who is correct? How do we know?
Because the apostrophe.
Because of the apostrophe. A prime is the bigger figure, so Shelley was correct. Okay, we will stop right there. Guys, can you please stack your binders vertically?